for my AI, databases, and computer graphics courses that describes how to prepare a term project proposal, as I often request of students at the beginning or towards the end of the first or middle of the second month of the course. Courses with term projects include my Introduction to Artificial Intelligence course, undergraduate independent study courses, database system concepts, data mining, Introduction to Computer Graphics, machine learning and pattern recognition and computer graphics courses. Certain courses have a literature review requirement for research that is very similar to the kinds of introductory literature review that are conducted for theses and for MSE reports, that is reports for the MSE project. So these include CIS 798 and 890, CIS 830 and 990, and occasionally I will actually refer students who are doing a research thesis or an MS project, especially for the first time, to this tutorial to kind of go over what is expected for 890, 898 and 899. So this is a set of guidelines. The initial write-up, which I even request from PhD students when they ask me to be on their committee and are basically preparing their depth exam, or perhaps preparing for a dissertation topic, to choose a dissertation topic, is to write about 1 page. This is basically a simple, short abstract, very straightforward, usually 3 to 6 paragraphs, but think of this as basically 5 main paragraphs in a reasonable font size. And what you're looking at here is making a broad statement about what the work is going to be. So the first is a problem statement, the goal and the technical objectives. What are you setting out to do? And so if you haven't chosen a particular topic, you just want to choose one of several topics, the first thing you should do is see the instructor and come talk to me, and we can go over possible project topics. So for example, in my computer graphics course and in my machine learning course, there are a lot of problems that people have worked on over the years that can be adapted to something that might interest you. But sometimes students just have new ideas. For example, in databases, they might have a database that they really want to actually deploy as a fielded system at work. And so they've thought about a particular application that they want to use. Towards the research side, people in 830 might have something that's actually related to their MS thesis and a thesis topic that they haven't actually completely scoped out yet. So these courses are a good way to actually develop some preliminary work. Not all of these courses are research courses. So for example, 636, 730, 530, and 560 are all courses that have often had undergraduates in them. And so the expectation there is that it's okay to reproduce existing work and to make your project primarily an applications project. But you should make the scope of your project roughly equal to or slightly greater than the scope of about 2 longish machine problems. Okay, so if you take the first machine problem in the course, which is pretty long, double that. That's about the amount of work that should go into the actual implementation, plus a little bit of time to actually write up the report. Okay. I'm not expecting anything more than that, because we're basically talking about a quarter of the credit in a 3-hour course. So the second section should discuss the background and related work, and it should include at least 1 to 3 references. It should include at least 3 references, of which 1 to 3 are actually available in print. Okay, I generally require that at least one of those be actually primarily print reference, and it's always preferable if you actually go to the library and get that print reference. But if you can't, just remember that there are things such as interlibrary loan, and you can go into ACM Digital Library and IEEE Digital Library. We have a pretty well stocked or pretty good access to these references. If you have any trouble finding these references on reserve or getting them through interlibrary loan or via our reference library, please let me know or let the teaching assistant know. The third section should deal with the methodology. And here we're not just looking for things such as I'm going to write this in C++ or Java or C#. We're asking you to think about whether you're going to use a server-side design. If you're actually going to use server-side architecture, is it going to be based on JSP or PHP? Are you going to use Java database connectivity or open database connectivity, depending on which actual implementation language you use? But more to the point, what approach are you going to use? So if you say, I'm going to render something in OpenGL, switching gears for a moment to look at computer graphics projects, real-time rendering is interesting. Are you doing character rendering, or are you looking at modeling of objects that have only a few moving parts? How hard is it going to be to rig this model? Are you going to use Maya to rig this model and then export it to Ogre 3D, or are you going to do all of the modeling by hand using generalized cylinders in just plain OpenGL, or are you going to use some combination of this? Are you going to build your scene using Milkshape, or just using Maya itself, or something even simpler than that? Are you going to actually specify emissive lighting, or are you going to just use point light sources? These are things that you have to decide, and try to specify as much of these as you know how to specify at this point in the course. But if you're not sure about certain things, it's fine to say, I'm going to have a texture-based and shading-based pipeline, and this is what's going to come out. Okay, that's for computer graphics. For machine learning, you might say something like, I'm going to use Weka, but I'm going to use these types of inducers in Weka, and I'm going to combine them in the following ways, and I'm going to apply it to this kind of data, and you have to think about what kind of pre-processing is going to be required for that data to make it useful for training. Okay, and this is true for advanced AI as well. So if you're doing an inference project rather than a machine learning project, you might look at existing automated reasoners, such as Prolog, Clips and Jess. Are you actually going to use an expert system shell, a production system, logic programming language, an imperative programming language, an ontology builder such as Protege, etc. In CIS 730, there are all kinds of topics such as the trading agent competition and its supply chain management variant that we look at, and also we look a lot at computer role-playing games, MMORPGs, video games, things like that, and you should look at what the interface is. Definitely don't waste too much time or spend too much time developing the graphical user interface, even if it's a graphics course, because there's a lot more to the course focus that is probably more relevant to you. So reuse what you can. This is not a full Master of Software Engineering project, so I don't expect you to maximize reuse to extreme levels. You should specify what the evaluation criteria are. Even if it's purely qualitative and you're going to say, I'm going to look at it and see how photorealistic it is, you should have some idea what criteria you're going to use. Am I looking at the photorealism of the lighting, the textures, fidelity of certain models? I'm going to take screenshots of the lighting model. If we're talking about machine learning, you should think about precision, recall, what your actual validation approach is going to be. If we're talking about databases, you should say, here are my test cases. So there's some level of unit testing and integration and system level testing, which I'm going to actually have you go through in your last 3 machine problems. Okay. And then finally, you should give a rough calendar. And this is just by bi-weekly period to a month. And then later, you'll replace this section in your final report with the results. Okay, and some screenshots of the system if appropriate. To write a good proposal, you should do enough footwork. Make sure you actually understand the state of the art, what your novel contribution, if any, is. If it's not a research course, you might just specify what is your own design. What are the strengths and weaknesses of the existing systems that you've seen, including commercial systems that you can buy off the shelf. Be flexible. Be prepared to actually fall back from your proposal a little bit. There should be a little flexibility so that you don't come to me with 2 weeks left in the course and say, I need to completely change topics because I just can't do it. Okay, what you want to do is have some flexibility built in so that you can drop back functionality if necessary, and be very modest about how much you think you can actually get done. Okay, that's always tricky because everybody's ambitious at the beginning of an AI course, for example, and people tend to be more enthusiastic the first few weeks of the course than they do the last few weeks because the holidays are coming or summer vacation is coming. So the scope of work is actually, these are my actual grading guidelines for the term project. Flexibility and originality, how much of it's your work, how much of it represents reuse. Functionality, code completeness, Okay, functionality here means does it work, and here we mean this means does it have all the features that you said you were going to have, and second, how much does it implement of what is actually needed to solve the problem that you specify. Okay, so there may be some discrepancy here that I'll discuss with you during your interim and final project interviews. The results, and some of these are quantitative, some are just screenshots, and then the final write-up itself has a grade. Okay. Typically, I have students actually write reviews of other people's final reports. These don't affect their grades, but it will affect yours, because the idea is to give you a little bit of experience actually writing a critique. So if you have any questions, feel free to write me or come to my office hours or send me an email for an appointment. See you in class.